Welcome to JAMB Physics Class. Let's focus on what kinetic friction. And this is going to be the second video. This is going to be the second video on frictional force. Now we are talking about the first video, which I talk about static friction, right? So static friction is a little bit easier than what kinetic friction. So if you have not check out the first video on static friction, please check out my YouTube channel here. You see frictional force 1, right? Go check out that video here. But in this video here, I really want to talk about kinetic friction, which is the main part when it comes to frictional force. So I'll be explaining the concept for you very well so you understand. Then I will explain what's called the parallel force and the perpendicular force, right? The acts on an object when it's sliding, when it's sliding down the inclined plane. Please pay close attention to this thing here because these are things JAMB normally like to ask in the exam. Just so and then I'm going to give a proper example questions that you can use to understand these concepts. So this is going to be like a part 1 of frictional force of what kinetic friction. So I'm still going to do like the second part. We are going to explain difficult problem, but now when this video, I want to explain what the key fundamentals. Do you understand? Now before I get into the class here, if you are new here, please consider subscribing to this channel because this channel is dedicated for your software when it comes to JAMB examination. So if you don't subscribe, you may not see my video again and you miss out totally. So now let's look at what frictional force. What is frictional force? So frictional force is the force that opposes the motion of an object already in motion as it slides across a surface. Unlike static friction, which prevents motion, kinetic friction resists motion but cannot stop it once the object is moving. It acts parallel to the surface in contact and opposite to the direction of the motion. Yes. So when we talk about frictional force, frictional force is the force that acts on an object that is already moving. The word kinetic means what? Moving, motion, right? Friction is the force that opposes to motion. So when you combine the two of them, kinetic friction is the force that is acting on an object that is already moving. So it opposes the object that is moving, but it can't stop it. Just and the word it can't stop it. So instead that frictional force always acts in the opposite direction to where the object is moving to. So it is the force that tries to stop the object from moving. And it's going to be on inclined plane here. See, please pay close attention here because I'm going to explain the stuff very well. So we are going to look at an inclined plane. I want to talk about an inclined plane. Now let us say this is the floor, right? An inclined plane is always at an angle to the floor here, right? This is an inclined plane. Now please pay close attention here. Now when you have an object or a bus moving downward, right? Moving downward here, right? So the ball is sliding with the force, right? Now the frictional force is the force that is acting or opposites. So you have frictional kinetic friction. Do you understand? Kinetic friction. Do you understand? Now if you look at the object here, the object has a weight. Now it is already moving down here, right? This is a natural force that is acting downwards. Do you understand? So this is what force under gravity. This one you are seeing here is force under. You can say force under gravity. So here you can say force under gravity. Do you understand? Here you can just say force under gravity because as you sliding down, what happened here? The G, gravitational acceleration, is actually acting on it. So here you call force under gravity. Please take down. Now you can also say force parallel to the inclined plane. So this force under gravity here, force under gravity, also not known as well. You also know what force parallel to the inclined plane. Do you understand? So please take it down. So this gravitational force you are seeing here, like understand this here. When the object is moving down, when you place an object in an inclined plane, what happens here? Now it's moving down with your force, right? That force that is moved down is force under gravity. You also call the force parallel to the inclined plane. Look at the inclined plane here, right? If you look at the inclined plane here, right? Look at the inclined plane here. This force is parallel to what? To the inclined plane. So this is the first force that is acting on the object. Parallel force. Just now, if you check very well, let me wipe this place out. I've explained this first one here. Now, if you check this thing here, there's always a what? The object always have a mass and the weight, right? So the weight is acting vertically like this. So this is the what? Is the weight of the objects, right? This is what is the weight of the object. So here you can say what? W. Now it acts vertically. Just that it acts vertically. Do you understand? Now, when the object is sliding down, there's always a force that hold. Look at something here. There's a force that holds this guy and so to slide down once. If there is no force that hold this bus and the inclined plane together, what? This bus will just slide once, right? So there's always what? A normal force that hold the bus and the inclined plane. So that force here is acting perpendicularly. It's called the reaction. It's called what? The reaction or normal force. So this force is acting perpendicularly. It's acting perpendicularly. So in the sense that, look at something here. Frictional force is the force trying to oppose this one from moving, right? Now, this guy here is the normal force, is the gravitational force that the object is used to move down. This is the weight of the bus, but we have a third force. What is the third force? The third force is what is normal reaction or the what normal force that holds this bus to the inclined plane that prevent the bus from sliding once. Do you understand? So instead that here we have three forces here. This guy and this guy are the same here. This frictional force is opposing this guy here, right? Now, this is the weight of the bus. This is the angle of the inclined plane. Do you understand? The angle determines how the bus will move, right? So this angle can also be here. Do you understand? So in the sense that if you look at the bus very well, now we have this one here. We have this inclined stuff here. It's perpendicular. When you say something is perpendicular to the inclined plane, it means that is what 190 degrees. Do you understand? When you talk about perpendicular, it means what 190 degrees. So yeah, we can have this one like this so which was 90, not 190, it's called 90 degrees. We call perpendicular 90 degrees. So this normal force here is 90 degrees to the inclined plane. Why this one is what is the parallel force here? Do you understand? Now we want to resolve this stuff. We want to resolve it. This is the what? This is the weight. This is the what? Is the so you have parallel force. Parallel what? Is it parallel force? Yeah. So you have the first force here. You have to look at is parallel. Number one, parallel. Parallel what force? And that parallel force is what gravitational force that the object is what put down. That's not what the gravitational force, gravitational force, which is parallel. So when this one move down here, now at this point as it move down here, is also this guy here, because this one also, if you move like this, it's also parallel. So this one I've seen here, let's say is x. Just so this x you are seeing here, this parallel for which you call the FG is here, because here we say S is called what x is okay. Now because we want to resolve it, please pay close attention. It's very important. We want to resolve it. Now the why is the here x equals to this one here, because this one is parallel, so it's going that is parallel here, right? Now which is what FG equals to what x here. Hope you understand. Please, if you're following this video here, please leave a comment section that you are. Please leave a comment section that you are following this video. I'm trying to see how I can explain for you to understand. If you don't still understand, also leave a comment section that you don't understand. Probably I'm still going to look for a better way to explain to you, because for me to come out with this video, I've read like 3 textbooks and I make my work proper research, and this is the best possible way for me to explain to you for you to understand. Do you understand? So if it's not still clear to you, you also leave a comment section too. But if you are following this video, leave a comment section that you're following this video, right? So here we have taken what the force here, the normal force here, the what parallel what force. Now number 2 is what is the normal is what perpendicular force, perpendicular force. I there which called normal force, called normal force, called normal force. I there and normal force is called Fn. So this one you are seeing here is what arrow and Fn, they are the same thing, right there. Arrow and Fn is the other. So they are the force that keep this box stable. Why this gravitational force is the one that is parting downward here. Then you have what the weight. Do you understand? Normal force. So my normal force here, let's just say here is what is y. So it can also be what y. Can you see that? Now number 3 is what kinetic friction. Kinetic what friction? Kinetic friction. I there kinetic what friction? Which what Fk. I there it is what it is the opposing force. It is the what is the opposing what? It is the opposing what force. It is the what force that opposes to what the motion of the object. This is that. Another thing you want to understand here is that number 4 is what coefficient of kinetic friction. Coefficient of kinetic what friction. I there which is what mu k. I there. So we are going to look at each and every one of them. So with this understanding here, I want to bring this out here. We are going to bring this angle out. It's okay. You are bringing this angle out here, right? So you have what my y. Yeah. Remember, here's what is my w, right? Here's what is my w, which is the weight, and here's what is what my x. Do you understand? So you can see the angle here. You can see this angle here. This is the angle you are looking at. Can you see that? So this one you are seeing here, I've already brought it down here, right? The weight, the x, the y, right? Please pay close attention here. So now to resolve this thing here, I'm going to use SOHCAHTOA in trigonometry ratio in what mathematics. SOHCAHTOA. SOHCAHTOA. Now what does it mean here? This s means what? Sine theta equals what? Opposite over what? Adjacent. Opposite over what? Hypotenuse, right? Opposite over what? Hypotenuse. Now cos theta equals to what? Adjacent over what? Hypotenuse. I don't know how to spell this, right? So now let's resolve this x first. Let's resolve this x. If we should resolve this x here, this x we are looking at which is the opposite. So we are looking at what? So if you have something like this, sine theta is equal to what? Opposite. Now remember, in a triangle, the longest side is what? Is the hypotenuse, right? The side that is opposite the angle is called the opposite. Right, the other side is what? Is adjacent. Do you understand? In what trigonometry what ratio? That is why if you are going from either medicine or study and you are not doing mathematics, now understand that for those medical courses like pharmacy, nursing, and the rest, right? And you're not doing mathematics, it's very good. You also know knowledge about mathematics. It's very important because it's going to help you. Some school bring what mathematics in their post-GME, but in JAMB you may not be doing mathematics, but at the long run it's going to be of help to you. Do you understand? So that is why I will advise you also take mathematics class, although not like that, but still pay full attention. So after your JAMB examination, they now hit on what? On the what? JAMB on the what? Math class. Do you understand? I'm also here for you to actually guide you during your post-GME preparation, not only JAMB, also post-GME what? Preparation. Do you understand? So let's get into it. Now, before I continue, if you know that you have not joined our private class, make sure you join our private class because you are missing a lot. There are so many things you will not see on this YouTube channel. They are kept for private students. And private class is where I teach you one-on-one, where I guide you one-on-one. It's going to be of great help to you. What was supposed to take you almost 4 months to cover, in less than a month you cover it, which is the leverage for you. Do you understand? Please, I charge my private class 101 privately monthly. Do you understand? Monthly, right? But it's something you can afford. So if you're interested in the private class, you send me a DM, you discuss the price, you join my private online 101 student. Do you understand? It's going to be of great help to you. So let's continue. Let's continue here. So when we talk about sine theta, which we call opposite, my opposite is what is x over what adjacent, which is what w, right? Which is what weight. Now, if you should what make this guy solve the formula, which is x here. Therefore, my x equals to what w sine what sine theta, right? W what sine theta. Do you see that? So here I have this component here. Here I have this one here. Now let's look at this y here. So which is what the adjacent. We're going to be cos theta. Cos theta equals to what? My adjacent, which is what is y over what w here, right? Therefore here I have what my y equals to what w sine what sine theta. Do you see that? Now another thing here is that remember w is what we're talking about w, which is what the mass times acceleration due to gravity, right? So you can say s equals to what m dot g dot sine what sine theta. Do you see that? Then the same thing here, y equals to what m dot g dot sine what. Yes, supposed to be cos theta, not sine. Cos theta, cos theta, cos theta. Can you see that? Now remember, I told you that my x is what is gravitational force, right? The gravitational force. What is the gravitational force here? Which is this one here? It means that this one here, which is x here, is what is. So you can write this one out to say what w sine what sine theta. So the gravitational force itself is what w sine theta when you resolve it. Do you understand? So this guy you're seeing here is what equals to what w sine what sine theta. Very important. So please take it down. Hope you're following here. So that is the gravitational force that acts downward is what w sine theta. Why the normal force? The normal force. We talk about the normal force. Normal force is what, which is what my y acting perpendicularly, right? Is what is w cos theta. So here we can say what Fn equals to what w cos what theta. Can you see that? So we know this guy here, we know this one here. In case say calculate what the gravitational force or calculate what the perpendicular force or normal force, you use this one here, right? Then what is what kinetic friction? Kinetic friction. How do you calculate kinetic friction? So I write this place as when we talk about kinetic friction. The kinetic friction, please pay attention. Kinetic friction here, we want Fk equals to what? The normal force equal F, no, coefficient of static friction, which is what? Coefficient of what? Sorry, coefficient of what? Kinetic friction times what? The normal force. The normal what? Force. This is the what? This is the formula here. Right there, this is what is formula here. And another thing I want to understand here is that this force for this bus to stop here, this force must be greater than this other one here. So at times they say this guy is also the same to this one here. Just but is what is at the opposite side. They are opposite. Do you understand? So for example here, this is what formula here. So if they ask you to calculate what the kinetic friction, right? You have to know the coefficient of kinetic friction and the what and the normal force using this this formula here. Just that try to get this one. Now let's resolve this coefficient of static of kinetic friction. Coefficient of what? Kinetic friction. Let's resolve it. If you what make this guy the subject of formula here, it's okay. You got to do what? Coefficient of kinetic friction equals to what? The normal force over what? The kinetic what? Friction. Do you see that? So now remember my normal force is what? What is my normal force? My normal force is what? Cos theta. My normal force is what? Called W cos theta, right? Over what? My frictional force is also this guy here, because these are equal to this one here, but they are opposites. Just that. So here you can also say W sine theta. This cancel out this here. Now when you look at it here, we can say coefficient of what? Kinetic friction equals to what? Cos theta over what? Sine theta. If you look at the trigonometry ratio here, cos theta over sine theta, you also know what tan theta. It's okay, you just know what tan theta. So this one here equals to what? Tan theta. Very important here. So in saying that this one is this one here, this one normal force is this one here. Now kinetic friction is this. It's okay. Coefficient of kinetic friction is this one here. So these are the what various formulas you need when solving what problem under what kinetic what friction. Under what kinetic friction. So you may not understand here until you start applying them in solving what question. So let's take one question in this video here that will clarify it for you very well. So now let's take this question here. Now this question explains every single thing you need to understand when it comes to what kinetic friction calculation. Just it explains every single thing. So I'm going to walk you through step by step on how to calculate this question here. Then by the end of this video, I'm going to change the value. Then I'll give you what as assignment. Just so please pay close attention. So let's look at the question together here. They say that a 20 kg block is placed on a rough inclined plane that makes an angle of 30 degrees with the horizontal. The coefficient of kinetic friction between the block and the inclined plane is 0.4. Calculate what the following. So let me just divide this board here. It's okay. Now remember when we talk about an inclined plane, this what let us say this one is an inclined plane, right? Let us say this one is an inclined plane, right? This one is an inclined plane. So the inclined plane make an angle of 30 degrees with the horizontal. So here is what is 30 degrees to the horizontal here. Now here is a block. Here is what is a block, right? It's okay. Now remember I told you that in an inclined plane, you have the frictional force that is acting opposite, right? Frictional what? Frictional force, which we call kinetic friction, acting oppositely, right? Then you have the gravitational force that is pulling it down, right? When we resolve it here, where I tell you that here, remember I tell you that when we resolve the results from here we say what W sine what sine theta. I hope you still remember here. Without that, I've already done it here. So that is the gravitational force acting on the object here is what is W sine theta, right? Then we have what the weight. It's okay. Here we have what the weight. And we know our weight equals to what m dot g, right? Now then we have what the normal force, right? Normal what force. And we have already evaluated our normal force to be what? To be what? W cos theta, right? It's okay. Which will arrow here, right? So here we have the 30. It's okay. Here we have the 30 here. So this is the weight. So now, what I want to do here, this is just a drawing of the inclined plane. You see that? So the first thing we want to look at here is what is the mass of block, which is what m, right? Which is m equals to what 20 kg, right? From here, let us get our weight, which is what w. So here I can get my weight. My w here is equals to what m dot g equals to what 20 times 9.8, right? Because the acceleration due to gravity is what 9.8. So 20 times 9.8, here we have what 196 equals to what 196 what Newton, right? So I've got this one here. Now they give me what the angle of the incline, which is what theta equals to what 30 degree, right? They give us 30 degree here. Now they give us coefficient of kinetic friction here. Coefficient of kinetic friction, which is what mu k is equals to what? It's 0.4. It's okay. Finish. These are the things we are being given here. Hope you understand. So now let's look at what the gravitational force acting down the plane. So here we can say A, calculating gravitational force acting down the plane. Calculating gravitational force acting down the what? The plane, which is what the inclined plane, right? So which is going to be FG. FG is okay, which is called the FG. Now remember, this FG also now what? The force parallel to what? To the inclined plane. Don't forget, the force parallel to what? To the inclined plane. What to be what? Which is what? W sine theta, right? My W here is only 190, so you can just say 196 times sine what? Sine 30, right? You bring your calculator here and get your answer. Bring your calculator and get your answer here. 196 times sine 30. So here we have what? 90 here. So my FG is equals to what? Is equals to what? 98 Newton. 98 what? Newton. That is, so I've got what my first one. I've got what my first one. Do you understand? Now let's look at what the B part. Now what they say should calculate in the B part here. The B, they say what? The normal force acting on the block. So you can say calculating normal force acting on the block. Now the way I'm explaining to you, that is how you have to write your notes. So by the time you go back and what, like reading your note again, like do revision, it's more easier for you. That is the reason why I'm writing it out here. Calculating the normal force acting on the block, which was Fn, which is also the same thing as arrow. Do you understand? The reaction equals to is what? W sine what? Cos theta. W cos theta, right? So let's impute our what? Let's impute our values here. My W is what? 196 times cos. My theta is what? Is 30. Cos 30 degree. Right? So here we have 196 times cos 30. So you have 169.74. So you have Fn equals what? 169.74 Newton, right? So we are done with what? A, we are done with B. It's okay. The force of kinetic friction. So look at what the C, force of kinetic friction, force of kinetic friction. Right, the force of kinetic friction. And the force of kinetic friction, which was Fk, is equal to what? The coefficient of kinetic friction times, or you can say times the normal force. Is okay. Times what? The normal force. Yes. Times what? The normal what? Force. Times what? The normal what? Force. So yeah, my K, my coefficient of kinetic friction here is 0.4. Here you can say Fk equals to what? 0.4 times my normal force I've calculated to be 169.74, right? What is the answer? So you have 0.4 times 169.74. Here we have what? 67.896 Newton. Can you see that? This is not the answer here. This is that. So now let's talk about the net force acting on the block. Now, what is the net force acting on the block? So I'll write this place here. The net force acting on the block. The net force acting on the block. So which is going to be what? D. D, calculating net force acting on the what? On the block. Right there. So it will be F what? Net. Now, if you look at the question here, let's look at the question again. We did not complete the question, so we have to complete the question here. We have to complete the question. The question I gave to you was not completed. Yes, I missed one part. The part I missed that the block is pushed up the inclined plane by a force of what? 150 Newton. Right there. The force is pushed up. The force is pushed up the inclined plane. So look at something here. There's one part I did not give to you here, which we need to correct. Right? So what I want to do here, I will complete that part here. I will complete that part here. This is that the block is pushed up the incline by a force of 150 Newton applied parallel to the plane. It's okay. So I missed this part here, so we have to include this part. It's okay. Now what about net force? Net force we call net force is equals to, please take it down. There's a formula here. Net force is equals to what? Is equals to what? Force applied, which was the applied force minus, right there, the applied force minus F gravitation, that is the gravitational force here, gravitational force plus the frictional force, right there, F, which was frictional, which we call what? Kinetic friction. Do you understand? So if you want to calculate the net force, it's very easy. The force applied minus the gravitational force we have calculated plus the kinetic friction we have calculated. Do you understand? That's how what you get your net force that acts on the object, in what? On the inclined plane. So the net force that applied, like the net force that applied on the what? On the object or the boss on the inclined plane is what? The force you applied minus the gravitational force you have calculated plus the kinetic friction. Do you understand? So here we can say F net is equals to, my applied force is what? Is 150. This is the force we apply. 150 minus my gravitational force u of 98 plus my Fk is what? 60 what? 67.89. Is okay. So let's see. So 150 minus 98 minus 67 is okay. Okay, plus 150 minus 98 plus 7.8. Here we have what? F net equals to minus 15.89. So now this minus, what does this minus mean? It means that the force is decelerating. Do you understand? The force is what is decreasing. That is meaning. So what is the last one here? The acceleration of what of the block. How do you calculate what the acceleration of the block? Calculating what the acceleration of the block. When they ask to calculate what the acceleration of the block, that is the E. Calculating what the acceleration of the block. Calculating the acceleration of the block. So which is what? E. Calculating acceleration of the block. So if you have been asked to calculate the acceleration of the block, what is it? Here going to be what? The acceleration equals to what? Force, which is what? The net force over what? The mass, which is what? The m. It's okay. The net force over what? Or over what? The m, which is the mass. So what is my net force? My net force is what? Is minus 15.89 over what? My mass. What's my mass? My mass is what? Is 20 kg. 20 kg, right? So what is the answer here? So 15.89 divided by 20. So my acceleration here is going to be what? Minus 0.7945 meter per second square. What does it mean here? It means that this acceleration is what is deceleration, that is decreasing, that is meaning. It means that this one is deceleration. Hope you understand. So that is it for this video here. So this is the first part of what kinetic friction. I hope this video is helpful. With the understanding of this one here, you should be able to solve any other problems. You'll be able to solve any other problem you come across when it comes to what kinetic friction. Do you understand? Thanks for watching. If you want to join my private class, leave a message that you want to join my private online class, or you chat me up for private online class, which I'm going to tell you price. Then you sign up for what class. We're going to teach you what one-on-one. Do you understand? If this video is helpful, please don't forget to leave a like and a comment at the comment section, and share this video with your friends who are also writing JAMB 2025. Thanks for watching. See you in my next video.